Thank you. Any questions from homework stuff or lingering questions for midterm or anything? Wafa, do you have some?
Yes, I just seeing missing at the midterm for 1 point, but when I submit the midterm, I just told you about that time, and when I go there, I didn't see that place to put that time I finished on it, like same quizzes. And until now, I see missing, but I don't know.
Yes. All right. So let me show you.
Okay.
Here, I'll pick on you a little bit here. Let's see. You're not the only one that did this. Right. So here you are, right? The student does not have a submission for this assignment, right? Now, is that a problem? Not really. But I did ask. Here, let me do something real quick. All right. Whenever you take a test or a quiz, and you know Canvas calls them all quizzes, okay? Here's the midterm. At the bottom of the screen was the text box, and then there's a submit quiz button right there. If you do not click that button, you never turned in your midterm. So it's gonna look like it did where it said this student is missing the submission of this assignment, right? The message I just showed you, that's going to show up for me if you don't click this button.
Okay.
And I can't even see the version of the test that you took because I can't see this, right?
Yes, I always did that when in the quizzes, but in the midterm, because we just told you about I finished and I submitted, and you say you
But
find good.
it's not going to hurt you at all. Do you understand?
Okay, thank you.
Not going to hurt you at all. It's just, please do that. Please hit that
Okay.
submit quiz button. Yeah.
Okay, thanks.
You're welcome. How's everybody else? You guys okay out there? If you, hopefully everybody is paying attention to their grades. If anyone is currently not doing as well, if you're currently not at a passing grade, you might want to schedule some time with me to go over some scenarios. If you make midterm corrections, how much would that increase your grade? We can talk about that. Any other quiz corrections that you haven't done yet, those would increase your grade. There's a phenomenon going on that my colleagues and I don't understand. The students who don't seem to care at all, they have a 20 or something, and like, all right, I don't understand that, but all right, but hopefully you're invested in your performance and you understand what your grade is. Does anyone not understand how to see what your grade is currently? Let me show you one more time just to be sure.
I have a question.
Yes.
I went onto Canvas and I could see where you have grades for the assignments I turned in, but I don't see an overall. Oh, wait, down there.
Yeah.
Oh, I don't think I looked at the very bottom though.
Yeah, the very bottom is normally where Canvas calculates the grades itself.
Yeah, I forgot about that. Okay, never mind.
Canvas does a horrible job of calculating grades, so I don't let it calculate grades. Once we take the midterm, it doesn't really weight things correctly and all this kind of weird stuff. Okay. By the way, the ones I just showed you was a test student. That was nobody in particular. Do you guys understand? The student I just showed you was my test student account. That was no particular person. Okay. Just in case anyone's worried, I just showed somebody's grades. So a few more people just came in. Any questions from homework or anything? Have you guys started trying out chapter 3 yet? No? Okay.
I started chapter 3.
Okay. I desperately need you guys to get into chapter 3. If you are currently working on chapter 1 or chapter 2 homework that you didn't finished before, stop doing that. Your first priority is always new homework. And then you do old homework if you're caught up with new homework. Hope that makes sense. All right. Okay. So let's get back into where we left off here. Let me see, where am I? If there are no questions from section 3.1 or 3.2, we're going to get into 3.3 because we are crazy people. So we got the snow cone stuff we did yesterday, finding x-intercepts and y-intercepts. The thing that always gets people confused is explaining what they mean. You have to explain to me physically what these mean. Can somebody tell me intercepts, y-intercept, x-intercept? What kind of thing is that? Is it a line? Is it a number? What kind of thing is a y-intercept?
Point.
A point. Good. So whenever you give me an answer for an intercept, it's got to be parentheses 2 numbers for a point. Is that cool? All right. All right. Some of you guys are going to be like, I'm going to take points off if you tell me the y-intercept is 7, because it's not 7. It's a point. It's 0, 7. And you can say, oh, you picky son of a bitch. And I'm like, no, it's just not right if it's not a point. All right. Let me see. Was there anything else we had to do here?
Professor,
Yes.
when we write our slope formula though, when we put in the y-intercept, are you going to want it to be like 0.7 or 0.07?
How do you,
As-
I'm not sure I understand.
How many? It's like y equals mx plus b.
Sure.
For the b, are you gonna just, if it's the y-axis, are you just gonna want like
So
a
here's the
whole
thing.
number?
The two things. One, we haven't really officially discussed mx plus b yet, right? I just sort of brought it up to see who remembered it. We haven't really officially discussed it. But the second thing, the b is defined to be the y piece of the y-intercept.
Okay,
So
yeah.
the b is just a number. Yeah.
All right. Thank you.
That's why I think once you learn that, you start to mix it up. And so when I say what's the y-intercept, you just say 7 because that's what b is. But b is just the y piece. Okay, I like it. Okay. All right, so today so far, very boring, very technical, and that's just the way things are. Okay. Any other questions about 3.1 or 3.2? So what do I have up here? Can you guys see the 3.2 homework up here on the screen right now?
Yeah.
Thank you. So just to show you some examples, what you're gonna have to do, you're gonna have to plot some points. No problem. We've been doing that for a while now. Finding intercepts. Once you plot them, you're gonna find the intercepts. You're gonna find the slope, right? Let's see. Blah 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 blah. And there's nothing really too crazy here, I don't think. You got to get into it so you can see if you understand all the little parts to it. But it's basically everything that we've done together. Okay. All right, so we're gonna get into 3.3. And the interesting thing about 3.3, this is one of my favorite little things here. By the way, real quick, let's talk about this for a second. I kind of love this. Real quick, does everybody, what kind of problem, do you guys know what kind of problem this really is? Anybody ever seen like a right triangle here and you have to find that side? Does anyone know what that problem is related to?
Finding the perimeter.
No?
Geometry?
Geometry, that's right. There's an old Greek dude who made a theorem.
Pythagorean
Yeah.
theorem.
Does that sound familiar? And we're not going to talk about the Pythagorean theorem now, just for a second. This is obviously funny, right? What did this problem mean? Find x. It meant figure out how long this side is, right? But then the student, I can't really fault the student. They found the damn thing, right? I found it.
That's
There it is.
hilarious.
All right. And I thought maybe, I don't know, has anyone ever seen this little thing before? I love to put it on syllabi and stuff. I don't think I put it on our homework sheet, but I put it on some other homework sheets. Anyway, that I there's less silly examples of me making questions on tests where I get an answer kind of like that, but I can't be too upset because I didn't really ask the question well. Does that make sense? So this just kind of reminds me to be careful. Just because people might not understand the question, or I might have some smart asses, right? I myself am a recovering smart ass. So I have smart asses in my class that will take full advantage of when I say something like this, they do this, and then they're kind of like, yeah, take some points off. Try to take some points off. I'm like, God damn. All right. Anyway, sorry. So this section, what we're gonna do, this is the idea of this book. We kind of discussed the idea of intercepts and slope. I sort of floated out the equation for the line, for a line, right? Y equals mx plus b. But now we're going to talk about equations in general. We're slowly kind of building up to the equation y equals mx plus b. We're going to get into like pure algebra stuff. So I don't know if you guys understand, this class is not purely algebra. Have you caught on to that? This is not your traditional algebra class, but here comes some pure algebra, which Jeff just loves the shit out of, but that's all right. I don't know how you guys feel about it. Let me get this guy set up. Here we go. So I already said the difference between an expression and an equation, and an equation is pretty easy to tell. Right? I mean, it's in the word. An equation has an equal sign, right? So this statement below contains a variable quantity. Is it always true or always false? Blah, that's barf. Get out of there. Stupid. Let me see. They're getting way too deep too quickly. All right, so let me do this. I'm going to do some stuff up on the board. And then I have a little handout too. Let me pull this over. Did I highlight myself? No, let's spotlight me. There we go. It's all about me. All right. So let's do this. I'm sure at some point in your math careers, you guys have solved equations, correct? All right. So let's do this. All right. Is this a true statement here? This is ground shaking.
Yes.
Yep.
Let me see. That's too dark now. See what I can do. Hold on. Yeah, sorry. Gotta work on my lighting. All right, that's not too bad. That's ground shaking. I understand. Now, watch this. If I multiply both sides by 2, does the statement remain true?
Yes.
Holy shit. And then if I add 2 to both sides, does the statement remain true?
Yes.
Yes, incredible. And if I divide both sides by the same thing, does the statement remain true?
Yep.
Yeah, it's crazy. All right, so what I'm trying to get you guys to realize is if I have an equation, all this is saying is some number I don't know is equal to 4, right? Is there something I could do to both sides so that actually it will tell me what X is? Something legal that I
Yeah,
can do.
Subtract 2 from each
Yeah.
side.
Yeah.
If I subtract 2 from each side, it is still a true statement, correct? If I subtract something from both sides, it is still a true statement. So if I consider that what they gave me is true, and I do something like this, it's still a true statement. So therefore, I know that x is 2. All right, now stay with me, Here we go. So what I like to do, first thing is, let me ask you this. Where do equations come from? This is going to be like the birds and bees of equations. Where do little equations come from? Where do they come from? Does anyone, that's a weird question, I don't care. Does anyone have any idea where equations come from? I love this question. It's so awkward. Where do equations come from? Does anyone know? All right. So one answer would be a teacher makes them up, right? I just make an equation up. I just did. Look, where'd that come from? Out of my head. There you go. Where do equations come from in the real world? They come from observations that we make, right? I can set up a relationship between two things. I'm like, oh, the later in the day it gets in the morning, the warmer it gets outside. Are you guys, does that make sense? Normally, are you with me? So as the day gets later and the sun gets higher, it gets warmer out. That's amazing. I can set up an equation relating the time of day with the temperature. Are you guys kind of with me? It's a very basic example of what I'm talking about. Have you guys ever seen, I know we live in California, have you ever seen a hurricane track? Have you ever seen that? Like, I used to live in Florida. That's a very bad Florida. And you'd see like a hurricane, holy shit, Jeff. And they'd have this track of where the hurricane was gonna go. Have you ever seen that?
Yes.
All right, how the hell, where'd that come from? Where'd that picture come from? Are they just guessing? Are they just pulling it out of their ass? No, there's an equation that they have created. There's actually many equations, to be honest, but they set up equations that relate stuff like humidity in the air, where the jet stream is, the temperatures, what direction it's already going in. They have this equation set up that they can then feed in the numbers of what's currently going on, and it can predict where the hurricane's going to go. All right. Sorry. I really want you guys to be with me. What I'm trying to tell you is this. We're going to learn how to do equations, and the equations we work with are going to come from bullshit. They're just going to be made up stuff. Equations in the real world are not made up stuff, but when we're learning how to deal with them, I'm just going to make some up so we can kind of mess with it. Are you with me? Does that make sense? Okay. Because I always wonder if students kind of have a disconnect because the equations we work with are very often purely made up. And you're like, this is just a bunch of letters and numbers and we're just playing around and what the shit. And it's like, no, the real world equations come at us. We have to know how to deal with them. So we want to have some practice. Okay. So now watch this. This is kind of neat. Somebody give me a number.
8.
8. That's crazy. All right. So let's say that I know that x is 8. Now, somebody else help me out. If x is 8, what must 3 times x be?
24.
24. Holy shit. All right. Now, if 3x is 24, is everybody with me so far? Nothing amazing's happened yet, right? Doesn't that just make sense? If x is 8, then 3 times x is frickin' 24, Jeff. Yes, that's fine. What is 3x minus 4 then?
20.
20, right? Nothing crazy has happened. Are you with me? Nothing crazy's happened. Of course it's freaking 20. If 3x is 24, then 3x minus 4 is 20, Jeff. What's the point, Jeff? All right, here's the point. This is what I want you, I'm sorry. This is what I want you to keep in mind when you are solving equations. What you're trying to do is to undo the shit somebody did to x. Up here, I know what x is. I did shit to it, now I don't know what x is, correct? If you just saw that, can you tell me what x is without thinking about it? No, it's buried under all this stuff that we did. So how can I start to undo this stuff? So if I take this away, how can I start to undo the stuff that was done? Couldn't I get rid of this -4? How do I undo the fact that somebody subtracted 4? How would I undo that?
You would have to add 4 to each.
Add
side.
4. I love it. If I do it to both sides, it's still a true statement. Do you remember this? Yes. And then, of course, how do I undo the fact that we multiplied x by 3?
You would have to divide each side by 3.
Divide by 3. So I like to think of solving equations as unburying the poor variable. The variable's been buried under all this weird shit, multiplying and adding, subtracting and dividing, all this weird shit. And we're just trying to undo that. We're trying to pick up the rubble and get the guy, come here, X, I'll help you, right? Maybe. So there's let me come back at this problem. All right. Can somebody tell me if you see this problem, why would you not want to divide by 3 first? Do you see how we added 4 first? Why would you not want to divide by 3? Let's go ahead and try to divide by 3. You ready? We're going to divide by 3. Here we go. Divide by 3, divide by 3. Does that look good? Does that look like a smart thing? Does that look like something I want to work with? No. So there is an order, and the funny thing is, I'm trying to undo. Stay with me now. I'm trying to undo a bunch of stuff somebody did to X, right? So it should kind of make sense that if I'm trying to undo something somebody did, I'm sort of going through order operations backwards. I'm going to add first. And then I'm going to divide when I would normally do it the other way, but we're trying to undo stuff. So that's why we're kind of going at it in reverse order. All right, let me stop for a minute. I don't know if anybody's ever kind of told you this. I've been trying to develop a more intuitive way of looking at equations, right? And equations are so fundamental to algebra that I think we should really explain more fundamentally what the idea is. All right, so you guys try this one here. Let me give you one that's not too crazy. All right, go ahead and solve that. Don't say anything. I want to see some writing happening. Go ahead, you guys solve that. Uh-oh, I keep losing people. All right, somebody, I'm trying to adjust my levels here, but oh well, okay. Yeah, so somebody, one person tell me, what's the first thing you do?
-7.
Subtract 7.
Subtract 7. And see, I'm being very nice to myself. I'm writing down what the hell it is I'm doing. I'm immediately doing it to the other side also. Because if I only do it to one side, my equation is no longer true. Yeah, I understand. Lost your internet. Now somebody else tell me, what's the last thing I do here?
Divided by 2.
Divided by 2.
Why am I dividing? Why not subtract 2? I don't know if that's a weird question. Why not subtract 2?
Because with the times, with the multiplication, we use division. With the subtraction, we use addition.
Only way to kill the 2 is division, because the 2 is multiplying. So of course I have to use the opposite operation. The only way something can cancel is if it's being acted on by the opposite operation. So solving an equation is doing the opposite, doing the opposite, doing the opposite over and over and over again until you get the variable by itself. How can I check this answer? How would I check it?
We
Sorry?
can put it at the beginning. 2 times 4 plus 7 equal 15.
I like it. So you plug it in. So supposedly x is 4. So if I plug it in, I can see if this is a true statement. Yay! So you can always check your work. So when I get to the end, here's what this means. When I get x by itself, this means when this is true, when x is 4 is true, so when x actually is 4, then this is true. That is what it actually means when you solve an equation. X equals a number. When x equals that number, when that's true, then the original statement is true. All right, I like it. So I know I'm getting into some details. I don't know if any of you have ever heard some of the stuff I'm saying right now, but this is the reality of what solving equations is. Okay, I think sometimes teachers kind of fly through this pretty quickly when this is like one of the most important things you could do in an algebra class is learn how to solve equations. All right, I'm gonna erase all this. So how would I solve this equation?
Would you have to
Multiply 11 by -5.
All right, is that what you're gonna say, Trisha?
Sorry.
That's all right. So again, you ask yourself, so here's what you kind of ask yourself. Why is the x not by itself? Stupid 11. Okay, what's the stupid 11 doing? Dividing. All right, so how do I kill it? I kill it with multiplication, not with fire. I don't know why I put a dot there too. So now you can see the 11s cancel. So x equals. Where'd that come from, Jeff? I don't know. I have a dot thing today. All right. Now, I understand some of you guys are probably very good at solving equations. You're sitting there going, yeah. All right, I don't care. That's fine. That's fantastic. Enjoy it if you have no trouble with equations. I'm talking to the people that might have some trouble with solving equations. All right. Let me think. Do I want to try to step this up? Sure. I do have a handout. I'm trying to figure out when to transition. Let's look at this. What if, let me see, how do I say this? Yeah, all right. What if I have this? 2x plus 3 equals x minus 4. Now, how is this equation different from any equation we've seen before? Or today, that we talked about today. How is this equation different?
You have 2 x's.
I have 2 freaking x's, right? I have an x on both sides. What the shit? So why were the problems before easier to work with? Because x was only on one side. So therefore, what just makes sense as to what my first step should be? I should try to get all my
X's to
The
one
x is
side.
in one
You
side.
move the x over there to 2x minus x
They move-
Good. So it's always, if I want to get stuff together, if I want to move something from one side to the other, I want to make it cancel on one side so it effectively moves over there. I don't want X to be here. I want only X's on this side, for example. It doesn't matter which side, but sure, we'll pick this side. So now they're gone. And of course, what's this?
X.
Good. I'm always worried somebody's going to say it's 2. But no, 2 X's minus an X is 1 X left. So then the plus 3 is still here. The equal sign is still there. And then negative 4 now. I'm trying to be a little, I don't know what the hell that word is. I'm trying to show you how to be nice to yourself. Many times people do shit all over that. They're like 3 and 4 and the X's and the stuff, and then they throw it all in. That's insane. You've got to keep track of where things are. The X's are here, the 3 is here, the equals is there, and the negative 4 is there. If you try to do stuff on the side and then bring it back in, they might end up on the wrong side of the equation. You're never going to get it right. You know, that's not good. Okay, now what's the last step here? Kind of obviously.
-3.
Yeah, because if I said to you, does this make sense? What's in the wrong place? What's in the wrong place? I have my X's by themselves. Yeah, the 3 is in the wrong place. It should be over there with the numbers.
Mhm. -7.
-7, I like it. Now let me see. Take a minute and see. Can you check this answer? Can you check it? Don't say anything. Can you check the answer? Can you see if it's correct? Don't say anything.
You are silent, Professor.
That would be fantastic. This is pantomime math. All right.
Yeah,
There's
that's
the original
correct.
problem. Sorry.
That's correct. We checked that.
Oh, you
I
got
checked that.
you did, you got it. All right. So, but how do you check it? X is supposed to be -7, so I'm just going to put a -7 wherever I see an X. I like it. So 2 times -7, -14. -14 plus 3 is -11. And -7 minus 4 is -11. Check.
Professor, I have a question.
Yes.
What if we move 2x to another side with the x?
Ooh, all right. Let's do this problem again. Look at you. It's almost like it planted you. All right. So I'm going to erase all this stuff on the board and we're going to do the problem again. Okay. Okay. Shit. Somebody's got to help me remember what it was. 2x plus 3 equals x minus 4. Is that what it was? So,
Yes.
Wafa's question is this. Like I said a minute ago, it doesn't matter which side. I need the x's on one side and the numbers on the other side. So what if instead of subtracting x, what if I subtracted 2x instead? Right? It still has to work. It still must work. So let's see what the hell happens. So there they cancel. So I'm just left with the 3, an equal sign. What's x minus 2x?
-X.
Good. And then I got the -4 here. So let me ask you this now, because I love to be able to ask this. What's in the wrong place?
The -4.
Good. The -4's in the wrong place. It's over there where the X is. It's supposed to be over there with the numbers, right? So what do I have to do to get this out of here to make it die?
Positive. +4, sorry.
Because the opposite of subtraction is addition. That's crazy. Go away. So now I get 7 equals -x. How do I know I'm not done?
So when X is not negative X, right?
Yeah, I know I'm done when I have x equals something.
Mhm.
Right now I have -x equals something, so I know I'm not done. How the hell do I get rid of that negative sign? What is understood to be here in front of the x?
1
All right, so how do I get rid of -1 times x? How do I kill the -1?
plus times 1
No,
+1.
+1.
no, definitely not. How did we do
Oh,
this?
divided by, sorry,
Yeah,
divided
how
by.
did we do this?
Yeah,
Did we
divided by.
divide by because it's 2 times x. So over here it's -1 times x. How do I get rid of it? Divide by -1. So what's x?
-7.
And isn't that what we got before?
Yes.
Okay, I like it. I was gonna until somebody said something. I was gonna keep going crazier and crazier. All right, sorry. Okay. All right, I like it. I like it. Now let's do this. Let's transition to the handout. Just so I can show you it's there for you. All right, let me see. Let me pull you guys over there. Where is Canvas? There you are. Where? Oh, shoot. I'm in the wrong place. Marr. All right, hold on. Oh, I hope did I activate it? Wonder Canvas powers activate. All right, where? Maybe I didn't. Apparently I did not. So hold on, let me activate it. Good job, Jeff. There we go. Pop, pop. No, not you yet. Go away, go away, go away. Look what's coming. Oh, sorry. All right, sorry. Word problems. All right, sorry. So unit 3. So now if you go to Canvas, you should see a unit 3. And there's a solving basic equations handout. So what I kind of try to do is I try to capture, I sort of go over this idea because this is sort of related to how to check stuff, right? And then I try to give you an example like we did earlier where we started with 4 and we doubled it and we added 3, whatever the hell we did. So this is kind of like what I did at the very beginning, little example. And then I try to talk about what's the idea is to try to get x by itself. So this is just basically recapturing what I said during the lecture today, right? So you have this to kind of reference. So what I want you to do real quick, these should be very easy right now. Go ahead and do those 4 problems. Now, please don't let me, if you are having trouble with any of them, I don't mean to make you feel bad that you can't do it. But there shouldn't be anything too crazy in any of these problems. And notice I say solve and check. All right, guys, let's see. Shouldn't be too crazy. You guys still working? Okay, I'll wait a second. All right, guys. So number one, what would you do? What would you do?
We should add 11.
Okay.
Good. Whatever you do, you have to immediately do it to both sides.
Mhm.
It's the
Yeah.
only way to keep things balanced, right? So then what's left on this side is the x.
X 20.
I like it. So that's the answer. And then check. Whenever you do a check of any answer, you have to go all the way to the beginning. And right now, this is a very basic problem, but we're going to see bigger equations, more stuff to do. Whenever you check the answer, you have to go all the way to the beginning, right? So at the beginning, it was x minus 11 equals 9. So when I put a 20 in, is that true?
Yes.
Heck yeah. All right. I like it. So if anybody out there is saying to themselves, man, this is easy. Okay, just wait. Now, who's got number 2?
You divide the x and the 3 and the 3 and the 12.
So divide by what exactly? Sorry.
Sorry, I stuck my throat. You divide
By
3
3. Okay.
and the negative 12 and the 3.
I like it. So right now it's 3 times x. The only way to kill that 3 is with division, right? You can't kill it with fire. These things just laugh at fire. Negative 12 divided by 3. Sorry.
Negative 4.
Negative 4. Okay. So that's, I know I'm at the answer because I got x equals. I like it. And then to check it, I start at the beginning. 3x equals negative 12. I throw in the candidate for the answer, and that's true. Shoop, 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 shoop. All right. Now, number 3 I like a lot because, all right, some people make a mistake on number 3 because you're paying attention to the wrong thing. What do I have to do? What's the first step in number 3?
Plus 8.
Exactly. So you don't say subtract 8 because it's adding. To be really honest, you would subtract negative 8. But what is subtracting negative 8? It's adding 8. And sure, I can see if I add 8, doesn't the number cancel? So you must do the thing that will make the number cancel, whatever you're trying to cancel. Yeah. So x equals
Negative 3.
negative 3. I like it. And then if I go to check it, plus x is negative 11. Negative 8 plus negative 3 is negative 11. Is that true?
Yes.
Yay! I like it. And then here, number 4.
Multiply to 6.
Yeah. So right now it's being divided by 6, my poor little variable. So I come in here to save it. I multiply both sides by 6. So then x equals
18.
18. And the check will be very quick. X over 6 equals 3. 18 over 6 equals 3. Yes. Okay. So those are obviously very basic examples of equations, right? All right, now let me show you something that might blow your mind a little bit. I don't know. So everybody got this here? Is everybody good with this? All right, I'm gonna stop sharing. I'm gonna erase all that. You ready? Here it goes. It is gone. Okay. So watch this. Here we go. Here we go. Here we go. First thing I want to do is, all right, so we're going to take a couple of little steps. We're going to do a freaky problem, and then we're going to call it a day. All right. So we'll see if you guys agree with me that it's a freaky problem. So first thing I want to do is ask you, what would you do if you saw an equation like this here?
We should multiply 2 in the parentheses.
Yes. So don't you want to be able to eventually like get rid of the 11 and stuff, right? And right? Don't you want to get rid of the number? You want to have the variable by itself, correct? Eventually. Currently, isn't that 11 stuck inside of the stupid parentheses? It's stuck. So one of the first things I want to do in an equation is distribute anything, because that frees up those parts to be able to move around. Does that make any sense? So I currently can't add 11 to both sides because it's stuck inside here. So let me distribute the 2. Why don't I distribute the 2 to the 7 also? Is that, hopefully most of you guys are like, the shit, of course you don't. Well, why don't I distribute the 2 to the 7 also? Does everybody understand that's kind of a, hopefully everybody sees that's kind of a silly question, but I always have somebody do that. What's the 2 multiplying by? Just this, right? So of course I'm only going to multiply it to just that. So what do I get here?
2x minus 22.
Good. And what was this property called again? Anybody remember? Starts with a D.
Distributive property.
Distributive property. I like it. So this is the distributive property. Blah, 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 blah. So there's the equals 7 still there. Now, see, now that I've done that, I'm free to do shit. I'm free to move stuff around. What's in the wrong place?
22.
22. We're going to get our first example of a not so pretty answer.
29.
And then the last step is
Divided by 2.
you get a fraction, and why don't you care? Why do I not care that I get a fraction? Because I am done. I am done. Right? Except, is everybody okay out there? What's going on?
Yes, okay.
I see some
Why is
quizzitive.
the x just 29/2?
What else would it be? So let me back up a bit. All right, let me make sure you're with. So you're cool with this, right?
Yes.
All right. So then you have the 2x still here, the equals 29. And what's the next step? I want to get rid of that 2, right?
It would be 14 29.
Oh, I see what you're saying. I don't care. 29/2 is also known as 14.5. Sure. Right? Sure. But this is fine, and this is also fine. They both mean the same thing. Is that right? Okay. Maybe. Now watch. So here's where the freaky comes in. Oh, I lost her. Damn. I'm gonna erase this. Here it goes. So now watch this. All right, I love this problem. Okay. I'm telling you right now, this is a freaky problem. What would you do first?
Like if the last one, we first do the parenthesis in that side. 3x minus 15.
Now, does somebody remember what we do when we have x's on both sides? Do you want those 3 x's over here? Let's get all the x's on one side. So how do I kill those 3 x's? What do I do?
Minus 3x.
Now, I think it's really kind of cute. I think it's, now get ready. Students normally hate letters all mixed up in their math. But when you get this kind of problem, you guys desperately try to save the poor little x. You're like, oh no, save the x. No, let the damn thing die, right? What's 3x minus 3x? It cancels. So what's 3x minus 3x? It cancels. What do you have left?
Minus 15 equals 6, and this is wrong, you know?
Ah, but remember, when I get to the end, what does it mean? When this is true, then this is true. Is this ever true?
No,
So can this have a solution?
no.
No solution. Now, real quick, let me show you a much easier example of what we just did. I really want you to understand this is not math's fault. If I start with a bogus equation, math can't save it. So watch this. Can anybody, before I even write it down, can you think of a number that when I add 1 to it, I get the same thing as if I added 2 to it? So like 3, if I add 1 to it, it's 4. If I add 2 to it, it's 5. So is it equal the same thing? No. Is there any number? Is there a number that when I add 1 to it, it's the same thing as if I add 2 to it? Does everybody understand the question I'm asking? Can you think of a number that when I add 1 to it, I get the same thing if I had added 2 to it instead? Does that make sense? Does that feel like there should be an answer to that? Of course there's not an answer to that. If I add 1 to a number and if I add 2 to the number instead, it's going to be bigger when I add 2 to it, isn't it? It's never going to be equal. So sure enough, look what happens. Of course there's no solution. You're asking, I've set up an equation for a situation that can't happen. So that's what it means when you have an equation and you solve it and you get to something that isn't ever true. That means there's no solution. That means the equation was impossible in the first place. And there's a really easy example of a very basic equation that is impossible. I can't have something the same if I add 1 or add 2 to it. There's no number that could do that, right? Okay. Maybe. All right. Now, what about this? Here's another freaky example. So you guys solve this one. So solve that equation. So let me catch up to you. I'll do this.
2 minus 2x equals 2 minus 2x.
So let's get our x's together, right? Let's add 2x.
Cancel each other.
When is this true? That's a very strange question, but when is it true that 2 is 2? Is it ever not true? Not a trick question. Is it ever not true that 2 equals 2?
It's always true.
Always true. So then what's the answer to this equation? All real numbers. It is always true. In fact, doesn't 2 times 1 minus x equal 2 minus 2x, period? Right? If I distribute, don't I get this? So this is saying, when is this equal to itself? Always. Does it matter what I use for x? No, it's always true. So all real numbers work. Let's try a number. Give me a number. Give me a number. Anybody? Anybody? Are you guys there?
7.
7. So let's see. 2 times 1 minus 7 equals 2 minus 2 times 7. 2 times negative 6 equals 2 minus 14. Negative 12 equals negative 12. Check. Give me another number. Somebody else.
4.
Give me say again.
4.
4. So let's check it. 2 times 1 minus 4, right? Is that cool? Equals 2 minus 2 times 4. 2 times negative 3 equals 2 minus 8. Negative 6 equals negative 6. Check. No matter what number you pick, it will work. That's what this answer means. You can let x be anything and it will be true. Isn't that neat? A little bit? All right. All right. I think that's maybe we can have an early day today. Is that all right? You guys okay with that? I have a feeling you might be okay with that. Let's have an early day. We're done. We are done. Oh, I don't know. Real quick, don't leave. Did you guys notice?
Tomorrow, no class.
Yes, exactly. So if you look at the Zoom lecture link, class will not be held tomorrow because Jeff has a meeting every now and again on certain Thursdays. I think next week also I've got a big meeting next week. But I don't know yet how early I've got to meet with some other people. So just there's a possibility we're not going to have class next Thursday either. But Thursdays I have meetings every now and again. All right. So that means that I will see you next week, unless you come to office hours. I still have office hours tomorrow. Remember my extra office hours? So if you need those. Otherwise, you are free to go. Let me know if you need to hang out after.
Thank you, sir.
Thank you, Professor.
Certainly. All right, I'm headed out. I'll see you guys